We're going to do this problem, which is going to be a two-sample t-test. We'll talk about why that is and run through the procedure on the TI graphing calculator using the full functionality of the TI graphing calculator as a statistical calculator. The mathematics departments in two colleges were compared by giving a standardized test to a sample of calculus students from each of the two colleges. The results were as follows. We're given the sample size, the sample mean, and the sample standard deviation for the test score results in College A and College B. The question is, do these data provide sufficient evidence at the 0.05 level of significance to conclude that the two colleges yield different average scores on the test? The first thing is to realize that we do have independent samples here. We're not measuring an individual from a population twice. We actually do have two separate populations, and so that's why we need the two-sample t-test. The populations are independent, and even though we're not told we can assume normality in any way, it really doesn't matter because our sample sizes are sufficiently large. The only possible issue would be the selection of the students. We're told it's a sample, but not a random sample, so we may want to proceed with a little bit of caution here. However, we will proceed and first of all determine what our symbols will mean. We'll use mu sub A to equal the mean test score for College A, and mu sub B to equal the mean test score for College B. Our null hypothesis will then be that mu sub A is equal to mu sub B. That is, there is no difference in the mean test scores of the two colleges. Our alternative hypothesis will then be that mu sub A does not equal mu sub B because we're asked to determine whether we can conclude that the two colleges have different average scores, and so that's what our alternative hypothesis will become. The two colleges have different mean test scores. So in the calculator, what you want to do is access the functions in the stat key and go to the test menu choice. So I'll access the stat key and navigate over to tests, and what I want is option number 4, two-sample t-test. It's option number 4, so I press the 4 key. My statistics have already been entered into the calculator. I'm using statistics, not data. For the input, you would select data if you do have raw data in lists, and you have to enter that data into the lists of the calculator. We've been given the sample statistics, so we're going to select stats because we have sample data. And so I've got stats selected right here. So then you enter the numerical values that are given to you, the mean, the standard deviation, and the size of the first sample, those sample statistics, the sample mean, the sample standard deviation, and the sample size of the second population. Scroll down to continue entering parameters. This is the row where you enter the form of the alternative hypothesis. We have a does not equal sign, so we select mu does not equal mu sub 2, mu sub 1 does not equal mu sub 2. We always select no for pooled, and then we can either select calculate or draw. I'll show you both. If you select calculate, you must press enter, and then the calculator returns your output. So let's look at the output window. In our two-sample t-test, the output restates for us the alternative hypothesis in symbols. It provides us with the student t-test statistic, and we see that t is equal to negative 2.559, or rounding to 2.556. The p-value is 0.0115. We could round that to 0.01. The calculator gives us the degrees of freedom. I would report that as 145. And then repeats our sample statistics, and you can scroll down to see more output, and that's pretty much it. So our alternative hypothesis was shown to us, and also our p-value. So the p-value that we calculated here is 0.0115. At the alpha equals 0.05 level of significance, we can then reject the null hypothesis because p is less than alpha. If we reject the null hypothesis, that means we have support for the alternative, and the alternative is that the two colleges have different mean scores. But there is indeed a difference between the mean scores between the two colleges, and so we might want to do some further investigation and find out which college we think had a higher mean score. Obviously, in the sample, college B has a higher mean score. We could find out the magnitude of the difference by doing a confidence interval, and we may do that for another video.